My project focuses on increasing the speed in which we analyze all the radio signals we receive from space. We've been doing all our analysis on our local machines on our home server using a program called NTPCKR, which scores each radio signal from space based on how likely it is to be an ET. SETI at home, the program that people run on their home computers, it takes each signal and it classifies it. And then the work that NTPCKR does is that it looks at each signal after it's been classified. So for example, if a pulse is pulsating too fast for nature, it'll give it a higher score that says, hey, this might potentially be ET, versus like a normal slow pulse that it'll be like, oh, this is just natural, and gives it a lower score. Our database is astronomically huge, like over 10 terabytes big. So NTPCKR works sequentially, so it would take about 1 to 2 years to actually score the entire database. And my project is to cut that 1 to 2 year timeline to 1 or 2 weeks. NTPCKR breaks up all the sky positions into tiny pixels, and there's like a lot of high interest signals coming from that area. It gives that area a higher score. And then at the end of it, we get a list of the highest scoring pixels, and then we send that list to scientists to point their telescopes at to see if they can find anything interesting within that sky position. So NTPCKR goes through each pixel one at a time, and there's over 1 million different pixels, so that'll take a really long time to do. So my project takes each pixel and analyzes it separately on a different cloud computer. For this specific project, we're using Amazon Web Services, EC2, Elastic Cloud Computing, which is basically a huge cloud computing server. So individually, scoring each pixel isn't very CPU or memory intensive. So our goal is to break up the active scoring to just 1 million different smaller pieces and have each cloud computing node do that specific piece and then just send back the score. Right now, we're testing it on about 10% of our entire database. And that 10% has been dubbed the Tiny Sky. So we're testing it on Tiny Sky right now. So based on our estimates from running the scoring on Tiny Sky, it would have taken 1 or 2 years with the old NTPCKR, but with this method, it should take only 1 or 2 weeks. So before I came here, I was a community college student, and I came here through a program from the Space Sciences Lab that reaches out to community college students to do research at Berkeley, and I got accepted into that program. You know, when I started this, I had no idea what was happening. I came in, they gave me like 200 pages of radio astronomy stuff to read, all the SETI stuff, and I just got really into it. Basically chose this project just because it had to do with aliens, but after I started, I really got into radio astronomy and SETI in general. After the scoring program, we'll be able to look at if we actually picked up something recently. And if not, we'll have the proper back-end infrastructure to just keep analyzing the signals, and we won't ever have a period of time where we don't look at the signals. I'm curious. I mean, it's like one of the biggest questions. Is there life in the universe? Are there aliens? It's just kind of fun to kind of be able to be a scientist looking into that question. And if we don't find anything, we have our answer. And if we do find something, I'll be famous.